Today we're looking at lessons 3-4 to 3-6 for the quiz for geometry. So the first thing we need to do is write an equation in point-slope form, and they give you the slope and they give you a point. So you just need to know the form and plug in what you have. The form is y minus the y coordinate equals m times x minus the x coordinate. So if our slope is negative 1/4, that's going to go in for m, and then our point is 4, 9. The 4 is going to go in for our x coordinate, which is the x sub 1, and the 9 is going to go in for our y coordinate, which is the y sub 1. So we use y minus, and keep that the same, plug in 9 for the y coordinate. Then we plug in negative 4 for the m, which is our slope. We keep x minus the same, and then we plug in 4 for our x coordinate. So this would be our answer. Next, we write an equation in slope-intercept form of the line with slope 6/5 and y-intercept of negative 3. So if the slope is 6/5, the y-intercept, or the b value, is negative 3. We need to use slope-intercept form, which is y equals mx plus b, and plug in our slope for m and our b value, or your y-intercept, for b. And that would be our answer. Next, again, we're writing an equation in slope-intercept form. So this time they give us 2 points, negative 2, 6, and 2, negative 10. And we need to write an equation in slope-intercept form. But they don't give us the slope this time, so we need to find the slope first, if that's the case. So we're going to do our y values subtracted over our x values subtracted, and we get 16 over negative 4, or just negative 4 over 1. So that's going to be our slope that we plug in. But now we need to find our b value. So we need to use a point, either point that we're given, to plug in x for x and y for y to solve for b. So let's say we choose the first point. I'm going to put in 6 for y and negative 2 for x. And I need to solve for b. So 6 equals 8 plus b. And then I subtract by 8. So I get negative 2 equals b. And then I need to put it all together as an equation. So y equals negative 4x minus 2. Would be our equation. Next, we're looking at a word problem where we again have to write an equation. Whenever you're asked to write an equation and they don't tell you what form, usually you assume that it's going to be slope-intercept form. So we need to figure out the slope and the y-intercept. When you're dealing with word problems, the slope is usually a rate, but in this case we actually have 2 rates, it looks like. We have $50 a month and $2 per line. So we need to figure out which is going to be our flat fee for the month and which is going to be our actual rate. So if we are trying to write an equation that represents the total cost for a monthly service, let's just say for 1 month, then that means the $50 is going to be just a flat fee for $50. So that makes the $2 per line our rate. So if we plug it into our equation, the 2 is our slope, which is the rate, and the 50 is our flat fee, which represents the y-intercept. So that is our equation. Next, we're given a diagram where it says we need to determine if any lines are parallel and then state the postulate or theorem. So we need to determine what type of angles we have, and then we can use the converse theorems and postulates to have as our justification. So here's our diagram, and I'm going to be referring back to this a bunch of times. So the first one we're going to look at is angles 11 and angle 13. So that's going to be angle 11 and angle 13. Now if we move our screen, or if we move our paper to be vertical, okay, to look at this not from the side, we would be looking at this particular line, which is what they're on, and then we'd be looking at these two lines to determine whether they're inside or outside. So, one, you could see 11 is going to be inside the two lines that I pointed with yellow arrows, and 13 is outside the two lines. So one is inside, one is outside on the same side of the same line. So that's going to be corresponding angles. So we need to determine whether the lines are parallel that they're on. So that means we're going to use the converse of corresponding angles postulate, which is postulate 3.4. Next, we have angles 15 and angles 12. So angle 15 and angle 12. Again, you might want to adjust your paper so that the line is facing vertically, but in this case, they're on alternate sides of that line, okay, this line with the yellow, and we're again looking at the two lines here to determine whether they're inside or outside. So both of them are inside those two lines, and they're alternating sides, so we do alternate interior angles. And since again we're using them to prove the lines are parallel, we need to use the converse of the alternate interior angles, which is theorem 3.7. Now we have angles 13 and 21. 13 and 21. And these are both on this line. So the two lines that they need to be in or out of are going to be these two lines. So they're both on the outside of those two lines. So that means they're exterior, and they're on alternate sides of that line. So they're alternate exterior angles. So we're going to use the converse, since we're proving lines parallel, which is going to be theorem 3.5. And then finally, you don't even need to look at the diagram here, because the only type of angles that are that are supplementary or equal to 180 are the consecutive interior angles, which if we use the converse is going to be theorem 3.6. Now we're given the fact that the two lines are parallel, and we are given angle 20 is 64. We need to find angle 17. So if we go back, we need angles 20 and 17. Those, you can see, are on the same side of this line here. So that means we're looking at these two lines to be in or out of. So they're both inside that on the same line. That means they're consecutive interior angles, which add up to 180. So we need to take 64 and add it to angle 17, which we could represent as x, and solve for x. So x would be 116, or angle 17 would be 116. And then again, we have angles 15 and 19 here. We need to find the value of x, so we need to figure out how we set up these two expressions. So 15 and 19 are going to be here across from each other. So they are on opposite lines. So they are actually not related directly to each other, but we can relate them to each other by determining other relationships of angles. So let's say the angle 15 and 10. 15 and 10 are the same, so they're vertical angles. And that would mean if we're going around to get to 19, that would make 10 and 11 supplementary, and then 11 and 12 supplementary, 12 and 13 supplementary. We could do 13 and 20, those would be the same, and then 20 and 19 would be supplementary. So we could kind of go all the way around here, but eventually we would figure out that 15 and 19 should be equal to each other. So that's 4x minus 16 equals 2x plus 34. And we're going to solve for x. So we need to combine like terms. We get 2x equals 50, and we divide by 2. So x would be 25. Next, we're going to construct a segment that represents the difference from point D, or distance, I'm sorry, from point D to EF. Now, the distance from a point to a line always has to be perpendicular. So, we can't draw a line from D to EF from the actual point like this. Whoops. That would not be a perpendicular line. So we need to think about what would be a perpendicular line from D to F. That would have to be just straight down, and it would make a right angle. So this would be my line that I drew right here. Now we're going to do distance from a point to a line. So we need to follow the steps, and these steps are listed on pages 217. Actually, this particular problem is listed with the steps on page 217, yes. So, first thing we need to do is find the equation for the line, which is line P. So we have -3, comma, -3, and -5, -1. So we need to find the slope first. So we're going to find the slope here, subtract the y's over the x's, and we should get -2 over 2, which is -1. So that's our slope. Now we need to find our b value. We use any point, so let's say we use the first one, y for y, x for x. So we get 3 plus b. Now we're going to subtract 3, so we get b is -6. Now our equation then would be -1x minus 6. The next step we're going to do is we need to write an equation that's perpendicular to this particular one we just found, but that passes through the point that they give us for point M. So if we go back, they gave us point M is -1, 1. So we're going to use that to write our new equation. So we have -1 minus 6 negative 1x minus 6. That's our one equation. Perpendicular to that, we need a perpendicular slope, and then we need to find the b value using the point. So negative 1, 1. Perpendicular to the slope of negative 1 is going to be the opposite reciprocal. So if we make negative 1 into a fraction, that's going to be negative 1 over 1. We flip it, so it's 1 over negative 1, but then we do the opposite sign, so it's going to be just 1 over 1. So our new slope is going to be 1 over 1, or just 1. And then we need to find our new b value. So we have y equals 1x plus b, and that's where we're going to use this point that they gave us for point M. So 1 goes in for y, negative 1 goes in for x, solve for b. I get 2 equals b. So my other equation then is going to be y equals 1x plus 2, and we have y equals negative 1x minus 6 already. Now we need to find the distance between the two, but we need to solve them first. So we're going to solve for x and then plug x in to get y. So if we solve, we just put them equal to each other. Combine like terms. And divide to get x by itself. So I get negative 4, and then I can plug it into either equation to get y. So let's say I plug that into the first one. I get negative 4 plus 2, or negative 2. So my point is negative 4, negative 2. Now I'm going to find the distance between the two equations, so I need to use this point that I have, that I just found, and I need to use the point back where we were given it in the beginning, negative 1, 1. And I'm going to find the distance. Using the distance formula, so I subtract the x's, square them, subtract the y's, square them, and we get negative 3 squared plus negative 3 squared, 9 plus 9, which is the square root of 18. And we can leave our answer like that. Here we're asked to find the distance between each pair of parallel lines again, but notice that they're only equal to y. So we can just count. How do you get from negative 7 to 3? Think about almost on a number line, and that is going to be 10 units. So our answer here is 10. Here we're asked to find the distance between these two parallel lines, so we're going to follow the steps on pages 218 to 219. So we need to come up with first an equation that's perpendicular to one of these equations. So if it's going to be perpendicular, let's say it's perpendicular to the first equation, our perpendicular slope is going to be perpendicular from the slope of negative 1, so our perpendicular slope is going to be positive 1. And then our y-intercept, since we chose to do the perpendicular equation to the top one, our y-intercept is going to come from the other one. So our new equation is going to be y equals positive 1x minus 4. And we're going to now solve using the first equation, which we came up with our slope from, equaling to the perpendicular equation. So we're going to put them both equal to each other to solve. So x would be 1, and we need to find y. We can plug it into either one of these that we used. So y is negative 3. So our point is 1, negative 3. And then we use the y-intercept that we used for this equation, the perpendicular equation. To plug that into the distance formula. So the distance formula would be subtract the y's, square them, plus subtract the x's, square them. So we have negative 3 minus negative 4, 1 minus 0. We should get negative 3 plus 4 is 1, so 1 squared. 1 minus 0 is also 1, so plus 1 squared. So we get the square root of 2. And that's our answer. Now the last problem is similar to what we just did. Actually, no, it's similar to what we did in the first example where we have the distance between the point to the equation. So we're going to go back to page 217. If you haven't written down those steps yet, I would strongly recommend writing them down in your notes. And we're going to use those steps to solve again. So the first thing we need to do is find an equation for our new line. So our equation needs to be perpendicular to the one we're given using the point that we're given. So to make it perpendicular, we need to actually make this equation excuse me, into slope-intercept form. So we need to get the y by itself. So we get y equals, so we have 1.4 comma 0.2. Now we're going to use that to find our distance, and we also use our y-intercept. We use our 0.31 in the distance formula that they gave us. Subtract the y's over the exit, or subtract the y's and then subtract the x's and square. So we have 0.2 minus 1 is negative 0.8 squared. It's positive 0.64 plus 1.4 minus 3 squared, so that's negative 1.6 squared. That gives me positive 2.56. And if we add that together, I get 3.2, so the square root of 3.2. Usually you won't have the decimal as a square root, but since I made these numbers up, that's what it turned out to be. So the square root of 3.2. And that concludes our quiz review.